Today I wanted to talk about a few things. Someone had made a comment on one of the videos, the one about the receptacle that had burned up, and they asked some questions, and I think I'd like to address them today. The first question was, what does a good receptacle look like compared to 79-cent cheapo? Well, I have a few of them here on the workbench. We're going to look at them, and then I'm going to tear them apart and we'll see what's inside. And also they asked about a plug strip, identifying a plug strip. I have a plug strip here that I want to show you that has some issues, and I want to show you inside why they are not appliance rated for sure, and what's inside that plug strip and why that causes so many fires when appliances are used with plug strips. The question also was the direction of screw tightening on a receptacle is simply clockwise. Yes, but if you have the hook in the opposite direction, what happens when you try to tighten that down, that hook is going to spread out and it's not going to be tight and you're not going to have a good connection. Another question was explain the rule for matching wire gauge to breaker amps, and we're talking about copper wire, and number 14 wire you would use on a 15 amp circuit, number 12 wire you would use on a 20 amp circuit, and if you have a 30 amp circuit you would use number 10 wire. It's as simple as that. And also explain how that outlet that in the other room affected the outlet that burned up. Well, if you look, this is the configuration. That outlet in the other room where the heater was plugged in was fed through the outlet that burned up with the loose, because it had loose connections on the wires, because the wires were wrapped the wrong way on the screws, plus they weren't wrapped all around the screw, and they became loose. And of course you generated heat, and that's what burnt that receptacle up. So here you see, like I said, a little drawing I did of it, and that's why what happened. And that could happen with any connection. You just need to be careful. The outlet that the heater was actually plugged into, the wires were actually hooked properly. So someone just made a boo-boo there. You just have to use a lot of common sense when you're working with electrical. You know, use common sense and think about it, and think about what you're doing and what could happen and get you out of trouble a lot of times. Also, explain the danger and the correct way, if any, to tap 110 volt off a 220 circuit. Well, normally in your house, you're going to have 220 4-wire on your stove, and your dryer. Sometimes they, depending on the configuration. Your hot water tank is generally a 220 volt 2-wire with ground. Now that's 3-wire. So you normally won't see that. But in some cases, and years ago, what they were doing, they called it a multi-branch circuit, where you would take your 2 hots and a neutral in a 4-wire piece of Romex. So you have your red, black, and white and ground, your green, running out the circuits. And they would take 120 volts off of the black and the white, and 120 volts off of the red and the white. And the consensus is the neutral would handle the loads, because it's the same as your load panel in your home, where you have your hot 220 across both sides. And what we're doing was using a single pole breaker for each side of the load. Now, in that respect, at that time years ago, that was considered kosher and okay to do. But in 2008, I think it was, the code was changed, saying that any ungrounded connectors had to be disconnected simultaneously on a multi-wire circuit. So in essence, if you did that, you had to have a 2-pole 20 amp breaker connected. And normally you would not have a 220 volt device specifically for a circuit like that heater in that other room that I disconnected the wall mount one, and then tap 120 volt off of the 2 of the conductors. That's just a no-no. That's something you're not gonna want to do. So the NEC, like I said, requires that all the ungrounded conductors to be disconnected at the panel board. So the industry kind of got away from running. You won't find any of that anymore because they got away from the multi-wire branch circuits. You normally won't see that in any newer homes that I know of that you're not doing. So let's take a look at some of these receptacles. And of course, again, if you have any questions, hey, I forget things and I make mistakes too. I had enough of sparks in my life. But let's look at these receptacles and this plug strip I have. And actually, the plug strip had an issue, and it was an old one that I just had stored away in the cupboard, and I hadn't used it for years. I dug it out behind, out of a pile of stuff, and it's interesting what happened to it. When I opened it up, I said, So let's take a look at these receptacles first before I take them apart. Now, it's pretty easy to spot a cheap receptacle. This one is a vintage Eagle. And yes, I call this a cheap receptacle because if you look at the back, the ground strap doesn't go all the way through. And of course, you can tell it's old because it has the regular flathead screw terminals on it. And that's a cheap one. And actually, you can get receptacles that are plastic. This one's a plastic or nylon. I prefer the nylon. Working with receptacles all those years in my job, nylon holds up better. Plastic tends to crack and break and leave exposed. If you have an issue, it can leave exposed parts of live, hot receptacles inside. But this was a Pass and Seymour. This was a buck. This guy was a buck, and if you look on the back, it's all plastic. We're going to open this up, and I doubt that. I don't know how the grounding is in this thing, and I doubt probably the blades inside are cheap. But we're going to look at this. Take this 99-cent guy apart. Now this is an older Leviton. The ears are missing. It's a hospital grade. The ears are missing because it came out of an old UPS that I tore apart one day that I drug home that was defective, and I took all the parts of it. But generally the hospital grade, they say they have to pass extensive tests over the commercial spec grade, commercial, whatever you want to call it. But I suspect that they're pretty much close to built inside how the commercial grades are. You notice the ground strap goes all the way through, and you see the side connectors. Oh, and one other thing, working with receptacles, let me get it over here. I wanted to say, what type of screwdriver do you use for a newer receptacle? Now, you may look at that and think, okay, yes, it'll take a straight blade, and also with difficulty, use a Phillips head. And if you Phillips head when you're tightening, it's really easy to strip. But what they're using now, it's a square head. See that square head? You have a square head, and boy, that bugger fits in there real nice. That's what it's designed for, and you can really crank on them buggers and tighten them up good with a square head screwdriver. So that's kind of mostly all the new receptacles have that either for a straight blade or the square head. They work real good. I had another couple other ones I used at work. I don't know where they went. And my favorite receptacle out of all. Now, I put a lot of Hubbell receptacles in at work, and Hubbell makes their commercial grade, which to me is very similar to the hospital grade. Now, this is a Hubbell Snap. This is my absolutely favorite receptacle. I'll tell you why. Well, this thing is a commercial grade, okay? Nice and heavy and built. But why do I like these? If I was building a new house, I'd spend the extra money and put all these in. Or now this is a 20 amp here. I'm going to take this guy apart. Actually, I got a bunch of these real cheap on eBay for a couple bucks a piece. How about that? But look at the back. Where's the screws? Where's the wiring? Check that out. Check this out. Here is how you attach it. Once these are hardwired in, you never have to be exposed to any live wires. They just snap right in the back. Ain't that nifty? I like those. We use those in the hospital with all the new construction. Had these in them. And especially in the hospital, it's nice. You don't have to shut the power off to change the receptacle. You just pop them guys out. They snap right out. And we'll look at that nice heavy bus in there. Like I said, this isn't a hospital grade. It's a commercial grade. But there are nice heavy connectors in there. And it works real good. Even though, look, made in China, I have to laugh. Some of the new Levitans, here's one here. It's a commercial grade. It says made in USA. I think this one here, you can see I wrote down the cost on there. And here's a Eaton spec grade. It's similar. It's a couple dollar outlet, you know. And so you want to spend a few dollars, even if you're going to use nothing as extreme as this. You want to get a spec or a commercial grade, and that'll do you wonders, because they'll last longer. The plug retention will be much better, and they can take a little more abuse, especially if you have a high traffic area where like a kitchen. A kitchen, you're always plugging things in and out, in and out, in and out. That's why I bought some of these. Actually, this one's a white one. It should have been ivory. The other ones I got were ivory because I have a couple I want to replace in my kitchen, and those will do nice. Before we tear these apart, I wanted to talk about plug strips. And I talked about before about how they cause fires. And this is kind of a standard run-of-the-mill, the one I had buried. With a surge protector, a switch on it, standard run-of-the-mill. But again, it's something like this. You don't want to plug an appliance or a heater in. They do make appliance-rated plug strips. They're very expensive. The good ones, you'll see some of the trip light. You won't see this. You'll see actual receptacles mounted in the plug strip. You know you got a good one. And but this one I pulled out out of my pile of stuff there out in the garage, and I want to show you this, show you how cheap these are, and how you can have a fire in there with making heat from a current draw from an appliance for a long time. But look at this. Now, didn't that happen? This has a surge protector. Okay, they say surge protector. They put that little MOV across there. Well, actually, this guy, he's spent. There, they just took it off. It's burned up, this little surge protector, so he's cooked. And they do that because as they age, these things will go bad, and whatever caused it, I don't know. But you look at this connectors in here, and they're just flimsy strips, and they're expected to do a lot current carrying. And if you look close, you wonder how that can how that can retain a plug good and a good connection after a while. Because let me plug this in here. So you're drawing all that current for a long period of time, and what happens is these cheap metal bars here. Here's something that happened. Look, I plugged this one in and the whole thing moved. But these cheap metal, that's all they are. They'll overheat, and this is plastic. The next thing you know, melt, burn, fire. There was several years ago down the road from me, there was a house, and somebody had a heater plugged in, a plug strip on the second floor. It was sad. It was a shame. They lost the whole house. Luckily, they got out alive. Doesn't matter, even though they're circuit breaker protected. These things can start a fire even with a 4 amp continuous, 5 amp continuous draw. You're not going to trip the circuit breaker. And even a 10 amp, this thing's rated at 15 amps. I don't know what this breaker's at it, but by time anything happens, you got all that heat dissipating in here, melting the plastic, and that plastic burns once it starts. Man, that's it. And here's the back end of that. You can see the burn mark from that MOV that caulked it in there. So, but so let me open these receptacles up, and we'll look at what's inside. Okay, let's take a look at these. You be the judge. I was kind of surprised at the Hubble. I don't know, maybe it's a Chinese knockoff, but I'm sure the hospital grades have to be made much better. I don't have any. But let's look at the Vintage Eagle. And the Vintage Eagle, now you notice the connections here. Vintage Eagles, I mean, not too bad for general use. Has two. Well, it looks like this one is not really spring loaded. So you have one. I'm looking at what's moving when I plug that in. You have one spring loaded there on the connection. And what really got me wondering is the ground connection on here. I don't know how that ever maintained a good ground connection. There is no no spring retainers for the ground on this. So, I mean, if you look at this guy, there's really nothing there to give you good ground on this old Eagle. I'm not sure what they were thinking, whether once this is put together, whether it was tight, ran tight up on this, because there is a piece of one piece of copper there. Oh, I see it. Here, let me bend this out of the way. Right here, I see it now. Not real good though, but see it down in there. There's one piece of spring in there for the ground connection. But this old Eagle, you have one movable spring, looks like this one on here. And so what happens is, like this one's a little more spread apart, but when they get spread apart, they get loose. You don't have good retention. But this plastic, 99-cent Pass and Seymour, boy, that bugger was hard to get apart because it was actually glued together. If we look, it has a pretty tight one spring retainer. Let's see. Let's go this way. And okay, so you see It's the inside one that's spring loaded, not the outside one. I'm moving it there. And the ground, it had a very small piece of brass spring in there. I got this right. Let's see. Oh, I'm going backwards. I'm sorry. I would have went this way. Correct? One way or another here. Let me get it plugged in. I don't know. I don't think it goes all the way through. It just sits in there. It would just sit in there by the length of the plug. So it would just be retained in there like that, because it doesn't go all the way through. Nope. So not a very good ground system there. The Leviton hospital grade. Now you look on a hospital grade, because this was this a 20 amp? Whoops, where'd it go? It might have been. Yes, it was no, this was a 15, but it looks like they say it has a nice, let's see, see the retainer there, what they did, and they have two spring loaded, and this side one on here, a little better hold there on this hospital grade. It's nice and heavy, and you can see this one's actually not worn out, but it's nice and heavy. And the ground they had pins here all the way down through, so it actually, and they're nice and heavy. Look how thick that brass is there. So it's going to hold pretty good on that ground prong, nice and heavy. And this Hubble, let's look at the Hubble here. The Hubble, he has pretty good spring retention for the. It's also the three fingers on there, the two spring loaded, the side one. So that's pretty good retention there for that. And nice heavy brass inside. The ground I thought was a little flimsy on this one. Let's see, it's going to go in like this, but it's another one that makes me wonder, unless this is a new one, unless I'm not pushing in. Here, you know what, I got another new one in the box here. Let's see what that feels like. Might be just tight. Oh yeah, yeah, oh yeah. Boy, I can hardly get that back out. That's how tight these guys are. Look at that. That's good retention there, boy. Wow. So it holds pretty good, and could be that this old Eagle, or I mean this 99-cent one, has very similar ground. See, I can't push it through there, but I don't think this one goes all the way through. Oh, it does, yeah, so it's pretty tight. So this 99-cent Pass and Seymour, I've seen some 79-cent ones that were a lot flimsier and not as heavy. You can tell by the weight of these things. And I've seen some of those that are pretty flimsy. But you can see the Hubble, you know, the inside, it's just on the thickness. And if they have the good ones have the three stabs there, whatever you want to call them, on the inside. On this other hospital grade, 3 stabs, same thing. And I said I haven't seen much difference. I've seen the commercial spec grade Hubbles and the hospital grade seem to be pretty dang closely made. And like I said, this has the, so, you know, there's the difference. Kind of a difference there. So, I don't know, make what you make of it, but with a cheaper outlet, you're not going to have as good ground retention. And again, I don't like these back wired where you can, let's see how this, let's put this back down in here. So how would that work? How would that hold the whole, okay. Wow, the wire would just go straight down here. Let me see. I don't care for the back wire, for the ones where you just push the wire in. Let's see, that would go from the back. Yeah, we'll go this way. So, something like that. Yeah, those will push in. Wait a minute. Here, let's go, this one's in. Let's see where the wire goes. Oh, actually, this is number 12 wire, so I can't put it in there. This is a 15 amp. So I don't have any. Oh yeah, here's a piece of 14. Let me see if this is 14. Yeah. Here's a piece of 14. Let's see. So this one may hold a little better than some of the others. This one had a similar setup in it. Yes, but you could see on this Eagle, it's just a cheap little, that's all you get when you push a wire inside. That's all that's holding that wire in there. So actually, because you can spin it around, that's not too, you know, that would be in a 79-cent cheapo. This one, this one's not too bad. Okay, it would be in from the back, so it would be, you can see how that wire is held in there. I mean, I can't see how that, you know, is that, you tell me, is that really make good contact inside there? That's, I don't care for these, but they got them on the market, and I guess they passed some code, but I just don't care for them. I'd rather wire directly, or the clamp type. This isn't a clamp type. Where's my screwdriver? This is just a, this receptacle is just made for a wire hook. The, so is this old Leviton. It's made for a wire, fish hook style. And the Leviton hospital grade, you see they have the nice clamps in here. And one thing, you can't use, we used a lot of solid or stranded wire in the hospital, and actually you can't fish hook solid wire properly. There's just no way. So these are a must for that. So you have a nice clamp affair on there. And oh, of course there's none on this Hubble because it was the snap style. But there you have it. You decide, but I say spend the extra money, get something with a little more metal and it'll have a better spring retention inside. And you spend a couple bucks, $2.50 over 79-cent. If you're installing a bunch of new ones, and especially if it's yours and you want them to last, especially in your kitchen where you have a lot a lot of traffic on your receptacles, in and out, in and out. So, have any questions or you want to yell at me about something? Lord knows I've been yelled enough about things. Any comments, leave them, and that's that. Have a good day.